So this is going to be, and I know you can't quite see it yet. Here we go. Section 10.3 is on the 6 circular functions. And the ones we covered so far, we covered the sine and the cosine. Okay? Sine being the y-coordinate, cosine being the x-coordinate of the unit circle. If I'm not talking about a unit circle, but I'm talking about some other circle that I'm rotating around, then I have to divide by r. So I like the unit circle because then I don't have to worry about dividing. I just go ahead and, I'm in great shape then. The idea that for each trig function, you have what's called a reciprocal trig function. Okay? So, what does this mean? This means that the sine of an angle theta is equal to what? Sure, opposite over hypotenuse. Now, I said that the sine was equal to y over r. And it's the same picture, right? If you orient your triangle so that we're doing circular motion, where again, this is initial side and this is terminal. And if I drop a reference angle, well, if I drop a perpendicular here, then my theta is right there, that rotation. And this is side of length r, and here's y. So you really do have opposite over hypotenuse, right? So we understand that. Well, the other trig functions, okay, are what you might call the reciprocal functions. See, because the trig functions are ratios, they're fractions, and the reciprocal, we know what that is. You take the fraction and what do you do to it?
Put over 1.
To get a reciprocal?
Or is it
You either do 1 over the fraction or you flip it, right? 1 over something. But the idea is that there are 3 reciprocal functions. So we have sine, cosine, and tangent. Okay? So the reciprocal of the sine is called the cosecant of theta. Okay? And Chashakayo would say cosecant of theta is take the hypotenuse and divide by opposite. Okay? Or if I'm thinking of sine as just y over r, then cosecant would be r over what? Over y. Okay, it's the reciprocal. So the cosecant is the reciprocal of the sine. Okay? And then this is talking about cosine, right? So the reciprocal of the cosine is called the secant. Okay? So maybe one other thing to say about the cosecant is that it's 1 over the sine of theta. The secant of theta, that's 1 over the cosine of theta. Okay? And then you have, the last one is called the cotangent of theta. That's 1 over the tangent of theta. So there are 3 reciprocal functions that we want to know. I'm going to pull my calculator out. You know, your calculator doesn't have buttons for these. You don't need them. Because if you want to know what the cotangent equals, you just compute the tangent and then do what? Flip it, right? Take the reciprocal, okay? So for example, here, let me pull my calculator out here. Takes me 2 steps here. There we go. So, I don't know. One thing I should probably check is what mode am I in, right? I'm in degree mode right here, okay? So if I wanted to compute, for example, well, you had one on the quiz. What did I ask you guys to do? I asked you guys to do the sine of pi over 3, right? Oh, wait, so if I'm in degree mode, what should I type in? Sine of what? sine of
Degrees.
60, right? That's the same as, I should probably just change the radian mode, but whatever. So I did this. And so you guys got, that, oh, what is that? 0.866. Yeah, that's one we memorized. That's the square root of 3 over 2, right? Now, on the picture up here, right, we know that the y-coordinate is the square root of 3 over 2. That's bigger than 1/2. So there's my 60 degrees, right? So it's the y-coordinate. Well, okay, so now what's going to happen in this section? We're going to be asking you about all 6 trig functions. So maybe I'm going to say, hey guys, can you find the cosecant of pi over 3? And that's very easy. It's the reciprocal. What's it going to be? 2 divided by what? Square root of 3. There you go. Okay. Now I think the book, if you look in the back, I think they're going to probably rationalize that. So they'll take that answer. This is fine by me, but if you want to rationalize it, we would multiply by the square root of 3 over square root of 3, and then we'd get 2 square root of 3 over 3, right? But that's what the cosecant equals, okay? So they don't even have a button for that. They'll just, you know, if you want to, well, this x negative 1 key, we know that a negative 1 exponent from algebra class, that means take the reciprocal, right? So this will do it right here. There's my answer. And let me just show you that if I were to take 2 divided by the square root of 3, I get exactly the same thing. So it really does work. Okay? So these are the 6, when I say 6 trig functions, there's 3 trig functions and then 3 reciprocal trig functions. And that's why the calculator really only has 3, sine, cosine, and tangent. Don't get confused. There's the potential for confusion right here. Do you see what's written above that sine button? It says sine negative 1. That does not mean cosecant. Okay? So, quick warning, I guess, I want to post. Warning. Okay? And that is that inverse sine of theta does not equal cosecant of theta. Those mean something different. To explain what inverse sine means briefly, see, every function has an inverse function going backwards. You guys did that in college algebra for sure. The idea of trig functions is that the input is an angle and the output is a number. This is also called the arc sine. It's the inverse sine. It means you give me the number and my function will give you the angle. But that's different from this, and so I just want to point that out right away. Negative 1 doesn't always mean 1 over. Sometimes it means inverse, and that's different in this case. That'll make more sense, I think, when we get into it later. All right. So I think the next thing I'm going to do is start doing some examples from your book. So page 759, if I just do number 1 for starters, they say, hey, can you compute for me the tangent of pi over 4? Right? No calculator. Let's just see if we can compute it. Well, especially if I have that unit circle handy, or if I know the unit circle, I've got this in the bag, right? Because the tangent of pi over 4, well, pi over 4 is the same as 45 degrees. It's there in green, right? I know that the cosine is radical 2 over 2. I know the sine is radical 2 over 2. The tangent, if I look up at my definition up above, it's y over x, right? It's sine over cosine. So what's it going to be? 1. You're putting radical 2 over 2 divided by radical 2 over 2. So that one's pretty easy. Number 2 asks for the secant of pi over 6. Okay, well, if I'm doing this one, I would probably write this is 1 over the cosine of pi over 6. right? Because the secant is the reciprocal of the cosine. And now the cosine of pi over 6, I'll get that from my unit circle. Let's take a look. What am I looking at? That's the cosine, right? Square root of 3 over 2. So I get 1 over the square root of 3 over 2. And so I get 2 over the square root of 3. You guys follow? Number 4. Cotangent of 4 pi over 3. Okay. First step, what would you do first? Kind of like here, I had a first step. I wrote it as 1 over the cosine, right? Oh, I guess I didn't show you enough examples yet. You know, number 1, I just gave you an answer, and I don't like that. I don't like that. I like to show my steps a little more. Otherwise, we're not learning. What I did was I did the sine of pi over 4 over the cosine of pi over 4. And since these were the same, that's why the answer was 1. Okay? Because tangent is sine over cosine. What about cotangent? What's that going to be? Well, it's the reciprocal of tangent, right? So instead of doing sine over cosine, I'm going to do cosine over sine, right? Or you could say x over y on the unit circle. That's right. So cosine of 4 pi over 3 divided by the sine of 4 pi over 3, right? So let's see what we get. Well, I guess I better look at my unit circle, and I better look at 4 pi over 3. And I guess one question is, where is that? I'm going to pause and let you work with someone next to you on this one for just a few, maybe half a minute here, and see what you come up with. And so I guess I look at that point and I say, well, that's farther down. So the radical 3 over 2 is the y coordinate, negative, and negative 1/2. Okay? And so now back to my paper. And so I say, well, this is negative 1/2 over negative radical 3 over 2. And so now you know it's going to be positive. You know what you could do is multiply top and bottom by 2. And what you get now is you just get positive 1 over the square root of 3, which is the square root of 3 over 3 as well. Okay? So that's how I would finish off number 4. Guys with me? Okay. Okay. I think we're fine on, say, 1 to 20. But then you get here, and it says, use the information to find the exact values of the remaining circular functions of theta. All right? So this is a different situation. I'm going to give you one fact, and you got to find the other 5 trig functions. Okay? And again, we won't need a calculator for these problems. We can base it off of a picture. Okay? So I'm just going to pick one of these and go with it. Let me go ahead and use number 23 maybe as an example. Okay. So for 23, they tell me the cosecant of theta is equal to 25 over 24. And they say theta is in quadrant 1. Does that make a difference? Well, yeah, it does. Okay. The fact that they tell you what quadrant it is in tells you what your picture should look like, and it's going to tell you something about, well, all the problems. Matter of fact, I think as another, I'll also do 22 as an example. I think that'd be a nice one to do. So I'll do 23, and I'll also do 22. So 22, we have the tangent of theta is 12 over fifths, and theta is in quadrant 3. Okay. So let me go ahead and start doing some work. So let's do 23, and then we'll go back and do 22. So for 23, I guess the first thing I would do is draw my picture. Okay. Now I know that theta's in quadrant 1, right? And actually, you know, what do we have to do? We have to find 6 trig functions: sine, cosine, tangent. And then what's the reciprocal of sine?
Cosecant?
Cosecant. So see, if I know that the cosecant is 24 over 25, you know, oh yeah, this one's 25 over 24. I just did the work in my head without realizing what I'm doing. If that's 25 over 24, what do you get for free? Sine of theta is 24 over 25, right? That's the sine. And so I'll tell you right now, remember that sine is also y over r, right? So go ahead and what we're going to do is we're going to draw our picture. Theta's in quadrant 1. And I'm going to draw something like this. I have my terminal side r, and y is almost as big as r, right? Y equals 25, or no, y equals 24. R is 25. That was kind of given to me, because they gave me the cosecant, which then immediately I have the sine. Okay? And now if you remember your geometry, you probably know what this x value is. Now what do I do if I don't know what x is? What would I do right now? I could write an algebra equation. What would I write?
Pythagorean theorem.
Pythagorean theorem. So you'd say x squared plus what?
24 squared?
24 squared equals 25 squared. And you would solve for x. And I will just tell you, though, that x equals 7. I don't know if you remember that. You could check it if not. There was something called a 7, 24, 25 right triangle. See, he picked really nice numbers for us. I guess normally, should I expect this to come out to be an integer? No. But, you know, he made it that way for us. So that's really nice. Of course, at this point, I'm all set, right? If I have that triangle drawn, I could do all 6 trig functions. Let's do it. So the cosine of theta, what's that going to be? 7 over 25, right? Because we know that cosine is x over r, adjacent over hypotenuse. And what about the tangent? Well, you can either think of it as opposite over adjacent, or you could think of it using our new definition, y over x. And so what do I get? 24 over 7. You guys with me? Okay. And there's only 2 more trig functions that I need. And those are the reciprocal trig functions. So the reciprocal of cosine is secant. And I guess right away I could say that the secant of theta is going to be 25 over 7. And right away I could say that the cotangent of theta is going to be 7 over 24. So I got it. I got all 6 trig functions. Okay? And that's the order you'd want to do these things. So I'm going to work out 22 now. A little different picture. Hey, by the way, 5, 12, well, we'll see if you remember any of that. All right, let's see. Same idea. Well, a little different. Here, I'm going to write over the trig functions over here. We need the sine of theta, cosine theta, tangent theta. We need cosecant of theta is the reciprocal of sine. Secant of theta is the reciprocal of cosine. And cotangent of theta is the reciprocal of tangent. And they gave me, which one? Tangent. They gave me that the tangent is 12/5. So right away, what do I get? Cotangent is 5/12. That's easy. Okay. The other thing I was given is that I'm in quadrant 3. So I'm going to use what I know about the tangent. The tangent is y over x. So let me draw theta, and let me make the y equal to 12 and the x equal to 5. In other words, my x is not as big as my y. Okay? You guys see that? So that's 5. That's 12. I'm in quadrant 3, and here's the terminal side. And so theta might look like this. Okay? Theta's in quadrant 3. You guys with me? And it's going to make a difference here. Because if you think about it, if I asked you guys, what are the coordinates of this point right here? What would you tell me? They're negative, yeah. -5, -12, right? And that's going to affect things. Now this r here, I can get r from the Pythagorean theorem, right? 5 squared plus 12 squared is r squared, but I'll just tell you that r equals what? 13. 5, 12, 13 was another of those fancy triangles. You're always going to want to write that r is positive, okay? And when I was taking trig, I remember I used to do this. Even though it's kind of wrong, I would write -5 and -12, just to kind of help myself. Side lengths can't be negative, but if I'm going to the left or if I'm going down, that makes the coordinates of the point negative. And so if that helps you, then go ahead and do that. Okay? Anyways, I'm going to pause and let you guys try to fill in the other 4 trig functions, and then I'll go on after that. I guess I'll just give you some answers then. So the sine of theta, right, is going to be, and you have to be careful here of your signs, it's going to be -12/13. Because, again, my definition is y over r, but y is negative because it's going down. Does that make sense? How about cosine? What's the definition? X over r. And so the answer is going to be -5/13. Okay? And then once you have those, these other ones are just reciprocals. So -13/12 and -13/5. Okay. I mean, I guess in some ways, the only things I'm really interested in maybe are the first 3 trig functions for now, because if I know that if you get the first 3, you can get the second 3 easily. So there's a few facts that I'm going to talk about today from the book that I want to go back to. I'll go back just a couple pages here. Just so that you can kind of see what they're discussing in the book. And yeah, we want to do that in a second. But let's start from the beginning and just make sure I've gone through and talked about these things. So you guys are okay with these identities here? The word identity means this is an equation that's always true, no matter what you put in for the variable. But you notice, I guess it's an identity, and they said provided that a couple things happen. To demonstrate what they're talking about here, why they say provided that, I really should do one more example with you. Here, let's do this. Let's do a problem like this. Let's suppose I tell you that I want you to find just the sine, cosine, and tangent of the following. Let's do the sine of pi over 2, the cosine of pi over 2, the tangent of pi over 2. And then we'll be good, huh? I think that'd be good to do. So if you guys could compute each of those, that'd be great. I'll pause for a minute. Pi over 2 is exactly what? 90 degrees. Okay, so you can use your unit circle, and we'll see what you get. The tangent, right? I mean, when you're talking pi over 2, the picture is that's 90 degrees, so I'm up here. And what are the coordinates of that point? 0 and 1. So the sine of pi over 2 is 1. That's no problem. The cosine of pi over 2 is 0. That's no problem. It's the tangent that gets me in trouble here, right? Because I'm trying to do y over x. So I do 1 divided by 0. That's undefined. Okay? So one of the reasons I think that we stay away from, when we start the class, we do sine and cosine. Because everything's nice for those two functions. But then you get things like the tangent where if I give you the wrong angle, you can't even compute it. Because we can't divide by 0. And that's going to be true for the other functions as well, because you might get something in the denominator that's no good, right? So if you take a look, well, if you tried to compute the secant of pi over 2, that wouldn't work either, because secant is 1 over cosine. And they say, look, if cosine is 0, then the secant could be undefined. You guys understand that? Mm-hmm. So that's what they're talking about here when they talk about reciprocal identities. But again, the idea of an identity is something that's always true, or almost always true. Now I'm going to jump ahead to, on page 749, there's a nice box of what are called the Pythagorean identities. Okay? The Pythagorean identities. And the only thing you've ever heard of Pythagorean is probably the Pythagorean theorem. All right? But I want you to understand something. These are really the same thing. So if you look at statement number 1, it says that cosine squared of theta plus sine squared of theta equals 1. So I want to draw a picture that shows you why that's the case. All right? And again, you know what I'm going to draw. I'm going to draw a unit circle. So let's do that. If we have a unit circle, so, you know, it goes through 1, 0, and it goes through 0, 1. And here's my initial side that goes through 1, 0. And so theta is some angle, and I'll just put it in the first quadrant. It doesn't have to be. So we know something. We know that this point xy is really, what are the x and what are the y? Cosine and sine. We know that. But the other thing we know is that if I drop a perpendicular here, and I draw what you might call the reference triangle, see, that's a nice triangle. Let me draw a bigger picture of it here. It's a right triangle, and I know that this angle is theta, because that's how far I rotated. Do we know any of the sides of the triangle? Well, we do, because this is x, right? That's the x coordinate, and this is y. But you told me that y is the sine of theta. And you told me that x is the cosine of theta. Right? Do I know the third side? That's 1, because we said this is a unit circle. All right. So now, what do? The Pythagorean theorem, of course, tells me a squared plus b squared equals c squared. And so if I take the cosine of theta and square it, that's my x squared, plus the sine of theta and square it, that's the y squared, that has to equal 1 squared. That's just the Pythagorean theorem. Does that make sense to you guys?
Yeah.
Okay. Now, mathematicians like myself are inherently lazy. We want to do as little work as possible. Even when it comes just to writing this equation down, I feel like I overworked myself, okay? So we have a shorthand, and that is we get rid of all the parentheses. But there's a problem with that. When you get rid of the parentheses, you might ask a question. Am I squaring cosine theta, or am I just squaring theta? And so we want to be careful about that. And so what we do is, if we mean we're squaring cosine of theta, we write it like this: cosine squared of theta plus the sine squared of theta equals, and then this is, of course, 1 squared is just 1. So this is like a shorthand that we'll use. We won't write those parentheses, but I want you to understand, from now on, if you see the squared there, that means we're squaring the whole cosine of theta. You guys understand that? So just to check this out, here, what would this mean? Cosine cubed theta. What would that mean? Well, it means take the cosine of theta and do what to it? Cube it. Right? You guys with me? So you figure out what the cosine of theta is and then multiply it by itself and multiply it by itself again, and you got it. Okay? So that's the kind of thing we're saying there. Well, what we have here is what's called one of the Pythagorean identities. Now, there are others. There are others. Let me go back to the book. Common alternate forms. Well, okay. Like, take that one. 1 minus sine squared equals cosine squared. Do you believe that? What'd they do?
Isolated the cosine.
Yeah, they said, let's get the cosine squared by itself. Let's subtract from both sides. You guys with me? So you can take an identity and you can do some algebra on it. As a matter of fact, number 2 is interesting to me. 1 plus tangent squared theta equals secant squared theta, provided that the cosine is not 0. All right, I'm going to work on number 2 for a minute. Number 2 said 1 plus tangent squared theta equals secant squared theta. And again, we understand what that squared means. Take the tangent of theta, then square it. Take the secant of theta, then square it. And it says, provided that the cosine of theta does not equal 0. Why'd they say that? Yeah, you don't want to divide by 0, right? And just for example, what does secant mean? Secant means 1 over cosine, right? Or tangent is sine over cosine. Anyways, where does that come from? Well, I'll show you. So why? Take the Pythagorean identity and divide by something. So the Pythagorean identity I wrote down was this cosine squared theta plus sine squared theta equals 1. Let me write that down. Cosine squared theta plus sine squared theta equals 1. What would I want to divide by in order to turn that into the red equation? Cosine? Right? I mean, if you're trying to get a 1 here, and if right now it says cosine squared theta, let me divide it by cosine squared theta, and it'll become a 1. Now, are you allowed to do that? Well, you're allowed to divide by something as long as you do it to both sides of the equation. So I also have to divide this guy by cosine squared theta, and I also have to divide this guy by cosine squared theta. Right? And I guess what you need to know now is that this expression here is the same as the sine of theta over the cosine of theta squared. And this expression here is 1 over cosine theta squared. And as long as you believe that, you're going to get 1 plus tangent squared theta equals secant squared theta. So there they are. You guys with me? So all these equations we just moved around, these identities, okay? It's kind of strange because we're taking these circular functions and playing games with them now, all right? And it turns out that this is really important in a calculus class. Now we're going to use it here as well, but I mean this comes up again and again. This is our first look, maybe our first exposure to what are called identities. And that takes practice, and that's one of the things I wanted to make sure I spent some time on today. Okay? So I think I'm going to finish the class by giving you guys some more practice with identities, okay? So, if I look at the book here, moving ahead to the exercises. Oh yeah, some of those angle of elevation ones are cool, but we did most of these. We did those. Oh, I might do 66 with you in a minute. Let me jump ahead. I wanted to look at these problems here, starting in the 80s. So it says in exercises 82 to 128, verify the identity. Assume that all quantities are defined. Hey guys, here, let's not worry about things like, oh, is cosine 0? If we're looking at pi over 2, is that going to be a problem? Forget about that for now. We're just going to see if we can verify the identity. All right? So, for example, 82. We want to show that that is really a true equation. That is true no matter what you put in for theta. Now, that one's actually going to be easy. You'll see. Right? So, 82 maybe that's a bad one to start with because it's like obvious. It says cosine theta times secant theta equals 1. And basically the question you guys are trying to answer here is why? Why is that true? Talk to each other for a second about that one until I pick up the next example. Fill it out. Again, the reason is because cosine of theta times, and then the secant, of course, is 1 over cosine theta. That's 1. Right? Something like that. What I usually do is I work on the side that's uglier and try and make it look like the side that's prettier. Okay? And I guess that's subject to point of view here, but here. Let's try 87. So 87 says we have the sine of theta over cosine squared theta equals the secant of theta times the tangent of theta. Is that true? Why is that true, is what I should say. They're telling me that's an identity. If it were me, what I would do here, I would work on the right-hand side. I would do this. I would say, hey, what do I know about secant theta, tangent theta? The reason I'm going to work on it is because I'm very comfortable with sines and cosines. Because those are just x and y coordinates. I'm more comfortable with those two than with the others. So secant theta, tangent theta, what does that equal? Well, secant theta is the same as 1 over what? Cosine theta. Tangent of theta, I can rewrite as sine of theta over cosine theta. And now I just have two fractions. If I multiply them together, I get the sine of theta and I get cosine squared theta, which is what we had started with. Make sense? That one's more worthy of my attention. And then I want to try one of these with the fraction. Let's try 92. That's a nice example. So 92 says you have sine of theta over 1 minus cosine squared theta equals, and then they say it equals the cosecant of theta. Okay. So again, you kind of have to pick which side you want to start with. I mean, cosecant theta, I don't have much I can do to it. I know that it's the same as what? 1 over sine. I would say that in this problem, I would start with this side. It's kind of uglier. So I'm going to go ahead and start with that. So again, the directions are we want to verify the identity. We want to verify this identity. So here I go. I'm going to write sine of theta over 1 minus cosine squared theta. Right? Ooh. There's a trick. So my hint is going to be the Pythagorean identity. What's the Pythagorean identity again? That was like 2 pages ago. Now I'm forgetting it. Yeah, we have this sine squared theta plus cosine squared theta, right? Cosine squared theta plus sine squared theta. I usually write it this way, actually. I don't know why. I guess I think of sines before cosines. Sine squared theta plus cosine squared theta is equal to what? 1. That's how I usually write the Pythagorean identity. So I guess the question is, how does that come into play here? Subtract the cosine squared theta. So you have, if I bring that to the other side, I can rewrite this as sine squared theta is equal to 1 minus cosine squared theta. And if you notice, that's what I have here in the denominator. You see that? Now I'm at a huge advantage. I've worked with trig functions for decades now. When I see 1 minus cosine squared, I immediately think sine squared. And eventually I want to get you to that point. Okay? It's not going to happen right away. You got to think. So you're going to need hints. All right? You got to sometimes look back at the, what have we been studying? Oh, there's an identity. Maybe I can use it and try it. So anyways, here I go. I now write sine of theta in the numerator, and what am I going to write in the denominator? Sine squared theta. Did that help? Why? What can you do now?
You can reduce it.
You can reduce, right? Now, is that true? Sure. Because like if you have x over x squared, you can cancel x's. So if you have sine over sine squared, well, you can cancel a sine of theta. What happens when you cancel 2 numbers? What are you left with in the numerator? A 1. And what are we left with in the denominator? Sine of theta. And what's 1 over the sine of theta equal to? Hey, we got it. We got it. Okay. So this is our first look at verifying identities. Yeah, I'd like to do this. At least 1 or 2 exercises with what are called angle of elevation or angle of depression. Okay? And they define it on page 753 if you want to look at their picture. But I'm going to go ahead and try a problem like this, number 79. So it says, when I stand 30 feet away from a tree at home, the angle of elevation to the top of the tree is 50 degrees, and the angle of depression is 10 degrees. What's the height of the tree? So what's the deal? angle of elevation and angle of depression. We're going to try and work through number 79 here. Okay, I want to draw a sketch. So, let me move that up a little bit. I'd still like to look at it though, so there it is. And so, I don't know, here's my house. Beautiful house. And I have a tree. And I'm standing 30 feet away from said tree. Make sure you guys have green. It's important. Beautiful, Paul. All right. There's my tree. There's the base of the tree. Now, it says I'm standing 30 feet away. So here I am. Kind of floating in the air, actually. All right, let me make myself standing. There we are. And I am 30 feet away. Right? And I'm going to then talk about what's called the angle of elevation to the top of the tree. The idea is that if I were to look horizontal and then rotate my eyes up until my line of vision just touches the top of the tree, that angle there, it says, is 50 degrees. You guys with me? Whereas if I rotate downward to the base of the tree, that angle is 10 degrees. And then since I'm standing 30 feet away, I can say that this line segment from here to here is 30. Okay, 30 feet, let's say. So what I want to do is I want to determine the height of the tree. So how do I get the height of the tree? Well, I guess what I want is I'll call this side A, and I'll call this little, from here to here, I'm going to call that segment A, and from here to here, I'm going to call that segment B. Okay? And so if I want the height, I guess what I can say is I just have to add A and B. And I think that A and B we can get using trigonometry. Right? So in order to do that, I need to write down a trig equation. So let's go for A first. What trig function do you think I want to use here? Now you got a 1 in 6 shot, right?
Tangent.
Why tangent?
Because you need to find the opposite side and you already have the adjacent side.
Okay, so you're going back to my good old SOHCAHTOA, right? So when I say tangent, being the tangent of theta is always opposite over adjacent, that's going to give it to me, right? So here, the tangent of 50 degrees is equal to, say, A over 30. And so what does A equal? A equals 30 times the tangent of 50 degrees. And if you follow that, well, now we're in great shape. Matter of fact, you could do the very similar logic, and I could say, what does B equal? B is equal to 30 times the tangent of what? 10 degrees. All right? So if I add those together, then I've got it. All right. Let me go ahead and get the calculator up here. And here I go. I will do 30. Oh, wait. I better check before I start calculating trig functions. What mode are we in? Are we in degrees? Yeah, we're in degrees. Okay. So 30 times tangent of 50. Okay, so A is about 35. What are the units? Yeah, because we measured the 30 was in feet, so this will also be in feet. 35.75 feet. And now, if I do 30 times the tangent of 10, That's another 5.29 feet. So it looks to me like my answer, the height is about 41 feet, right? So if I add 35.75, I'm at 41.03 feet. Okay, so that's nice. But once again, the mathematician in me is wondering, could I have done it, 41.04 feet, let's say. Could I have done it a little faster? I mean, I'm always looking for that kind of thing. Like I did 30 times the tangent of 50. I did 30 times the tangent of 10. Would this work? 30 tangent of 60. What do you think? No. Didn't work. Why didn't it work? Well, I guess tangent of, say, alpha plus beta does not equal the tangent of alpha plus the tangent of beta. There's something that's not an identity. But maybe we'll get one next time. That'll be a shortcut. All right, guys, nice work today. Drive safe, everybody.